Hello, hi everyone. Welcome to my channel. So here is chapter 3 part 3 angle modulation with Madam Hafiza. So let's recap back the chapter 3 part 2. So here is the Bessel function of the first kind, the table of Bessel function. So here on your left we have modulation index. Alright, the listed of modulation index. And followed with the carrier, the Bessel carrier element, and the rest is the sidebands. So here is the frequency spectrum. The y-axis is your amplitude, which is the unit is volt, and your x-axis is the frequency, which is in hertz. So here the middle spectrum is the frequency carrier, and together with the amplitude carrier, which is VC J node, the value. Next is the first sideband, followed with the second and the third sideband. So here is the equation for full FM. So we start with the carrier, VC J node cos 2 pi FCT. Next is VC J1 cos 2 pi FC plus FM for the first upper sideband, and then cos 2 pi FC minus FM for the first lower sideband. Continue with the second sideband, VCJ2 FC plus 2 FM, and then for the lower sideband, second lower sideband is FC minus 2 FM. And lastly is your VCJ3, which is the amplitude for third sideband, and then the third upper sideband FC plus 3 FM, and the third lower sideband FC minus 3 FM. So this equation is belong to this spectrum. Alright. So for the power in FM signals, so in AM, since the amplitude of the carrier signal is changed according to the input signal, so the total power of AM is equal to the sum of carrier power and the sideband. So here is the equation. P total for AM is equal to P carrier plus P sideband, which is lower sideband and upper sideband. So unlike AM, the amplitude of FM signal is constant, which is the total power in FM wave is equal to the power of unmodulated carrier. So the equation is PT power total FM is equal to power carrier unmodulated carrier. But the carrier power in FM is redistributed among the carrier and the sidebands. Thus, the total power the total power modulated is equals to P node plus the sidebands P1, P2 until the Pn, which is P node is equal to modulated carrier power. P1 is power in the first set of sideband, P2 is the power in the second set of sideband, and Pn is the power in the nth set of sidebands. So note that Pc is equal to Vc squared over 2R, same goes to the AM, and Pc, bear in your mind, Pc is not equal to P naught because Pc is the unmodulated carrier power, but P naught is modulated carrier power, which is after the modulation block diagram, and R is equal to load resistance. So here is the total power in FM, which is Pt equals to P naught plus P1 plus P2 until the Pn. So, or we can also write this as in full equation, Pt equals to, so here is the carrier power, which is P naught, the modulated power, and here is the sideband. So where V naught, V1, Vn are FM modulated carrier amplitude and sidebands amplitude respectively. So R is the load resistance. We will given, for example, R equals to 50 ohm. So just substitute the value of 50 ohm. Thus, we can use Bessel table and further improve the equation to this full equation. Next is the bandwidth. The higher the modulation index in FM, the greater the number of significant sidebands and the wider the bandwidth of the signal. So when the spectrum conservation is necessary, the bandwidth of an FM signal can be restricted by putting an upper limit on the modulation index. For example, in standard FM broadcasting, the maximum permitted frequency deviation, our delta F now, is equal to 75 kHz. And the maximum permitted modulating frequency, which is our FM, FM is 15 kHz, and we get the value of M by using this equation. M equals to delta F over FM, and is equal to 5. So next, how we determine the bandwidth. Alright, so we have two types of method for calculate the bandwidth. The first one is approximation Carlson rules. Bandwidth equals to 2 in bracket delta F plus FM. And another one is actual bandwidth, which is using the Bessel table. Bandwidth is equal to 2 N FM. N is the number of sidebands. So first, the bandwidth using the Carlson rule. So approximate the bandwidth necessary to transmit an angle modulated system is twice the sum of peak frequency deviation and the highest modulating signal frequency. So 2 in bracket delta F plus FM. So we know that delta F is the maximum frequency deviation and FM is the maximum modulating signal frequency. So second or lastly, how to find the bandwidth using Bessel table. So in Bessel table, we know that there's a significant sideband N, and also it depends on the value of modulation index M, and it can be determined mathematically using this equation. Bandwidth equals to 2 in bracket N times FM. Okay, N is the number of significant sidebands and FM is the maximum modulating signal frequency. So let's try this example. M equals to 0.25. So by refer to the Bessel table, it's given that for M equals to 0.25, it has only one sideband. So now the bandwidth is equal to 2 FM. Next, go to the M equals to 2. It has 4 sideband, 4 pairs of sideband. 2 and FM is equal to 8 FM because the number of sideband, the significant sideband is 4. Meanwhile, for M equals to 5, there's 8 sidebands here. So bandwidth for this modulation index is equals to 16 FM. So let's try example 1. If the highest modulating frequency 3 kHz and the maximum deviation is 6 kHz, find the modulation index and calculate the bandwidth using Bessel table and the Carlson rules. First of all, we need to calculate the M. So identify the value of delta F and Fm. We get the answer is 2. And then refer to Bessel table, m equals to 2, you will get the value of significant sideband is equals to 4. So by using this equation, bandwidth equals to 2 in bracket n times Fm, you will get the answer for this bandwidth. While for the Carson rules, here the equation, just substitute the value of delta m, delta F, and Fm, and you will get the answer of bandwidth using the Carson rules. So let's try this example too. For FM modulator with a frequency deviation of 10 kHz, modulating signal frequency of 10 kHz, the carrier amplitude given is 50 volt and the carrier frequency is 100 kHz. So determine the following question. The first one is the bandwidth using Bessel table, and the second one the bandwidth using Carson rules, and then lastly amplitude of the side frequency and plot the output frequency spectrum. So the first solution, we identify the value of delta F and Fm and substitute into this equation. And then now both the value for delta F and Fm is 10 kHz. So now m equals to 1. Refer to Bessel table. Using the Bessel function table, okay, here is the value for bandwidth using the Bessel function. Next, by using the Carson rules, we know that bandwidth equals to 2 delta F plus Fm. Substitute the values and you will get this answer, 40 kHz. Alright, so here is the value for modulation index and the rest of the carrier and the sidebands. So now we continue to the question C, which is we need to calculate the amplitude values and then draw the spectrum, frequency spectrum. First of all, we need to find the component of carrier and the rest of sidebands. So here is the modulated value. And now we draw the spectrum frequency. Here is the x-axis frequency in hertz, in kilohertz, and here is the amplitude in volts. So just substitute the value of modulated carrier, the pair of first sideband, the pair of second sideband, and the pairs of third sideband. So here is your FC, and here is your upper sideband, first upper sideband, second upper sideband, third upper sideband, and here is your first lower sideband, second lower sideband, and third lower sideband. So here is the additional question for example 2. So determine the unmodulated carrier power and assume RL is equal to 50 ohm, and determine the total power in angle modulated wave. So here is the equation to calculate unmodulated carrier power. PC equals to EC squared over 2R. EC squared, EC is 50 ohm. So 50 ohm squared divided by 2 times 100, we get 25 watts. For the total power in angle modulated wave, so here is the equation. Substitute all the information here. The V naught, the V1, V2 and V3, as well as the value of R, and you will get the total answer for power modulated signal is 25.12 watt. As you can see here, the difference between these two answer is 0.12. It's slightly similar to the unmodulated carrier because of the point of the Bessel function. So here is FM application. FM application are divided into two broad categories. The first one is narrowband and the second one is wideband. How we know the value of narrowband? By using this statement, the modulation index less than 0.5. So if M less than 0.5, it is the narrowband FM. While for wideband FM, the modulation index M is much greater than 0.5. So it categorized as wideband FM. So that's all for FM part 3, the angle modulation. And thank you everyone, and bye. Stay tuned. Thank you.